So, am I audible to you? And screen is visible to you? Just let me know in the chat box. Student of JNV Bhavnagar. There are so many students are there. Okay, so just let me know कि screen is visible to you and I'm audible to you. Okay, then we will start the class. You remember me, na? Okay. I'm the same teacher, but wearing these specs due to my eyes issues. Okay. So any one of you can respond. Then we will proceed in the lecture. Okay. Come on, guys. You can do it now. How do I get to know कि the screen is visible to you or not? Am I audible to you or not? Just make a quick response. Okay. We are live on the YouTube now. I guess so. Okay. Okay, so no problem with that also. Now, so good evening to all of you. I welcome you all in this session of question discussion on rectilinear motion. That is very important chapter. The point of view of physics, point of view of any competitive exam or your upcoming pre-board exams. Sorry, your final term exam that will be held. Okay, so it is very important chapter for the point of view each and every aspect of the physics. Okay. And let me start the recording. So this is a very important chapter, the point of view of physics, point of view of your academic growth, point of view of your competitive exams. It is very important. So what we will going to do, we will firstly we will revise some concept. Okay. After that, we will see the questions one by one. That is all we are going to do today. Okay. So please pay attention to this chapter because this is very important chapter. Okay. The first part we are going to discuss today, and the remaining part we will going to discuss on tomorrow class. Got it? But be responsive. Make this session very interactive. Okay. And do not feel bored. Okay. So firstly, we will discuss what the agenda that we have today, or what are the target that we are going to accomplish, that we are seeking to accomplish. Okay. So firstly, we will discuss what is motion and its type. Then after that, we will discuss what is distance and displacement, speed and velocity, then various form of speed and velocity. First is the instantaneous one, second is the average. Then after that, we will going to learn about the acceleration, and also in average speed and velocity, we will going to see some important cases where the average speed and average velocity need to be calculated. Then after acceleration, we are going to discuss equation of motion, not the derivation, only the equation of motion. And then the general equation of motion that we are going to do. So this is the target for today class, and hopefully we are going to achieve it. So be patient, be active, and be attentive in this session. Okay. Now, so firstly, if I talk about what is motion, so motion is nothing but a state that any body or any person or any system can achieve. And how this state can be achieved? This state can be achieved by changing position with respect to time. So if any person, any object, any system is changing their position with respect to time and with respect to the observer also, then we said that particular object, system, or particle is in motion. Got it? So there are two important points in motion. अब तक हमने जो पढ़ा है मोशन के बारे में, वी विल डील ओनली विद टू रीजंस, only the definition that we learn, that is change of position with respect to time is motion. No, it is incomplete. When a system or a particle or a person change its position with respect to time as well as with respect to the observer, then we can say that particular object or person is in motion. So here we have two factor. First is the observer and second is the time. Now time can we can measure from the watches, analog watch, digital watch. How to measure that? How to identify that observer? So to identify the observer, we define the frame of reference from where we are observing the motion. So based on that, we have two types of frame. First is the initial inertial frame, in which the object or the observer remains stationary or at rest, or if observer is moving, so it is not changing its speed, okay, moving with a constant speed. The second is non-inertial frame, when object itself changing its speed and then observing some other motions, then we can say that observer is in non-inertial frame of reference. Got it? So this is motion and how we describe it. Now, types of motion is uniform motion and non-uniform motion basically. Uniform motion is that motion in which speed is constant. But what about non-uniform? Non-uniform motion is that motion in which speed is not constant. Which means if you are moving with a speed of 10 meter per second, so in each and every second, you will able to cover 10 meter. So the distance covered in each second, each interval of time is same. That particular motion is uniform motion. And what about non-uniform motion? So in non-uniform motion, different distance distance covered in same time interval. Okay, which means if I talk about uniform motion, speed is, let's say for example 10 meter per second, so we will able to cover 10 meter in 1 second, then in another second the distance will become 20 meter for 2 seconds, 30 meter for 3 seconds. But if you talk about each and every second, 1 second may we have able to cover only 10 meter. Here on also it is 10 meter. Then each and every interval of time, the distance covered here is 10 meter. Got it? But if you talk about this non-uniform motion, we have this velocity, let's say 10 meter per second, but it is changing. So at another instant, the velocity will become 15 meter per second. At another instant, velocity will become 5 meter per second. So for each and every second, the distance that we covered is different. That is why this motion is termed as non-uniform motion. A motion which is not uniform. Okay. Now what is distance and displacement? So distance is very simple. Distance is the actual path traveled. Suppose you are uh, move a distance of 10 meter and then come back to the initial position. Now what is the distance covered? Distance is the actual path that you have taken. Okay, the measurements. So if you have moved by 50 meters, so 50 meter is the distance. But what about displacement? So displacement is the minimum distance between 2 points. Got it? The minimum distance that you have been covered between the 2 points, and that 2 points will be final point and initial point of the journey. So suppose in this example, A to B, the person has moved from A to B. It has covered a distance this. So you need to measure the path length. The distance is nothing but the path length. Okay. But displacement is the minimum distance. So suppose this is point A, and from point A you have moved a distance point B in a semicircular track. So what is the displacement? Initial point is this, final point is this. So what is the minimum distance between them? So you need to draw a straight line. So that is the minimum distance, and that is termed as displacement of the particle. Got it? Now, some key point remembering: displacement is a vector quantity, and what is a vector? Vector is those physical quantities which has magnitude as well as direction. So this displacement has also directions, and the direction of the displacement is from initial position to the final position. Now, the key factor here is, firstly, the distance is always greater than equals to displacement. No matter what the situation is, what type of motion you are counting on, the distance is always greater than equals to displacement. And the case when the distance is equals to displacement is only when distance is equals to displacement when motion is in straight line. So in that case, until the body or the particle take turns at that particular point, distance and displacement is same. Now, distance is never negative. ठीक है, कभी भी distance negative नहीं हो सकता. If you have moved a single step, that will also count. So distance can never be negative. Okay. Now, what is displacement? Can be positive, negative, or zero, because the vector quantity, it can be either positive, zero, or negative. Okay. Now, for example, if we have moved from A to B via ACB, okay, A to B, we have covered this distance. So what is the distance? 10 kilometer plus 20 kilometer. And then we again come back to point C. So what is the distance covered by this particle? It is 10 plus 20 plus 20, which is 50 kilometer. But what about the displacement? Displacement, we have final position minus initial position. So finally we are here at point C. Initially we have started from E. What is the distance between them? It is 10 kilometer. The displacement is 10 kilometer, and we are writing the magnitude of displacement, not the direction. Okay. In the second case, if the particle moves from C to D also, then the distance here is 60 kilometer, because 10 A to C, then C to B is 20, then B to C 20, then C to D is 10. So if you sum them up, it will come out as 60 kilometer. Now, what about displacement? The displacement is zero, because the final and initial points are same. So if you take the difference from them, it will become zero. Got it? So that is the case here. Now, speed and velocity. What is speed? So when the distance changes with respect to time, that particular physical quantity is termed as speed. And speed is a scalar quantity, which means speed has only magnitude, not the direction. So in the speedometer of your vehicle, it only shows the numbers 60 kilometer, 80 kilometer, 50 kilometer, not the direction. Okay. So that is why that particular physical quantity measures your speedometer is termed as speed, which is actually the distance per unit time, or change of distance per unit time. Or simply you can also say it, the rate of change of distance. Now, what is velocity? So simply, if distance and displacement has brother or sisters, like distance is scalar, displacement is vector. Similarly, when distance changes with respect to time, it forms speed. And when displacement changes with respect to time, it forms velocity. The velocity here is a vector quantity, which is nothing but rate of change of displacement. Very good. The speed here is change of distance divided by time taken, and velocity here is change of displacement, time taken. Now, for example, If v is equals to 10 meter per second and it is constant, then for each and every second, the distance traveled by 10 meter, then speed is constant. And that particular motion, remember, that particular motion is uniform motion. Uniform motion. Got it? Now, what about the instantaneous velocity? Instantaneous velocity is something that we get at a particular instant of time. So suppose you have started your journey at 9:30 and you reach your destination at 10 a.m. So if I ask you what is your speed at 9:39 a.m., then that particular speed is instantaneous speed because I'm asking the speed or velocity for a instant. That is why the speed and velocity for a particular or a specific instant is termed as instantaneous speed or velocity. Got it? Now, although if you take a look, just a little conceptual thing. Suppose this is the distance and this is the time. Okay. So we have measured a plot how the distance traveled is varies with time. Okay. No matter the motion is. But what if I calculate at this point of time? Let's say at this point of time. I have considered two time interval here. First is this, let's say T1, and second is this, let's say T2. In between them, the distance covered is S1 and let's say it is S2. Okay, got it. Now, if I talk about the average velocity, V average, what we can write? We can write the total distance covered in this time interval. The total distance is S2 minus S1. S2 minus S1 divided by total time taken. Total time taken is T2 minus T1. This is the average speed, no matter, no offense. And also it represents the slope of the graph. We will see. Okay. Now, but I have made the mistake here and you have didn't have realized it. Slope we only define for a point. And this is not a point. This is a specific amount of distance in between these two time interval. Okay. What if I started decreasing this time interval? Let's say I have considered this point, T2 dash. So what will happen? The distance covered will also change. Okay. What if I just take this time, T2 double dash? The distance will also decrease. Look how the distance is changing. Distance covered is changing now. Now, what if, let me draw it very clearly. This is the point T1 and this is the point that we are decreasing. So let's say I'm considering this T2 very near, very near to the T1. So what happened, T1 dash we will consider when this T1 and what we are decreasing, T2. When this time interval, T2 minus T1 is time interval and that we are constantly decreasing. Okay. So we can say when delta T tends to 0 at that particular time, is very small distance is being covered. If I take this point very near to this time T1, what happens? Very small distance has been covered. Okay. So for that, we can say this distance covered is similar to a point. Okay. And that particular, which means we are dealing with T1 only. We have just shifted, let's say, for example, T1 is 10 seconds. So the instant that we are taking is 10.00000001 second. So what is the difference between them? Difference between them is so less. So we can consider this T2 to be T1 as T1. And with the help of that, we are able to calculate, oh, we can say this is delta S by delta T, the big interval. But when we apply this delta T tends to 0. So for very short time interval, very less time interval, the distance covered is very small and the very small distance is given by ds. And dt is a very small time interval. And this velocity is instantaneous velocity. So this is the velocity that is instantaneous that we have calculated at t1 only. Okay, got it? Now, I hope you get it. And for this, if you draw a line passing through this, the ds by dt is nothing but the slope of this st curve. Okay, so the slope of st curve at particular point represents v instantaneous. And same for if we take s as displacement, then that particular speed is termed as instantaneous velocity. That particular quantity is termed out as instantaneous velocity. Now, the average speed and average velocity we have discussed. Average speed is nothing but total distance covered divided by total time. What is the average velocity? Average velocity is total displacement divided by total time taken. This is important, total time taken. So suppose you have started your journey from point A, you have moved to point B, okay, got it. But in somewhere in between A to B at point C, you have taken a rest for 1 hour. Let's say for 10 seconds, okay. And you have started your journey at t is equals to 0 second. You have finished your journey at t is equals to 50 second. Or let's say we will take the time stamp here. You have started your journey at 9:30, 9 a.m. Then you take a 1 hour rest in between A to B, in between your journey because you are getting tired at that point. So you have rest for 1 hour. Okay. And finally, when you reached at this point B, the time is 11 a.m. This 1 hour is also included in that. Okay. But some of you will say that for that 1 hour, we are taking rest. We are not moving. So how this time is need to be calculated? Because you are not talking about instantaneous speed. We are talking about the average speed. In average speed, you have to consider the total time taken because it already counts. Let's say this distance is 20 kilometer. Okay, your speed is not constant throughout. Some of you might have faced the breakers, okay, traffic jam and all. So this 20 kilometer take you 2 hours, in which include 1 hour the rest also. It suggests that you have covered this 20 kilometer in 2 hours, so that we can say that the speed of yours is 10 kilometer per hour average. So we can superimpose this average speed on your fluctuating speed. So we can say if you are doing that much of fluctuation, no worries. we can consider that you are coming to this destination by 10 kilometer per hour constant speed. Okay, but that speed is not a ordinary speed, that is the average speed. Okay, now I got you. I think you have got the differences. Okay, so move on to the different cases for average speed. That is important for the point of view of exam. Okay, now let's we calculate. So we separate the space in two form, and firstly we will calculate. Let's say this is the straight line. This is point A, this is point B, and this is point C. Let's say for A to B, the speed is V1. For B to C, speed is V2. Let's say A to B, the distance is S1. B to C, the distance is S2. Okay, so firstly, what we will see, what we will take, the time is constant. Means for this S1, the time is T, and for this S1 also, the time is T, which means to cover these S1 and S2, time taken by the body is same. So calculate the average speed. So average speed here, what is the formula? It is the total distance divided by total time taken. Okay. Now, what is the total distance here? Let me change the color. Total distance here is S1 plus S2. S1 plus S2 divided by what is the total time taken? Total time is T plus T, which is 2T. Got it? So what we can say, we can take 1 by 2 as common. We can say this is S1 by T plus S2 by T. So S1 by T and S2 by T is nothing but V1 and V2. Change of distance per unit time. Change of distance per unit time. So we can say that V1 plus V2 divided by, this is the V average. So we can say here V average is the arithmetic mean of all other speed slash velocity until the body takes turn. जब तक बॉडी टर्न नहीं ले लेती तब तक स्पीड एंड वेलोसिटी इज सेम. Okay, so if the time interval is same to cover the different distances, you just take the velocities, sum them up, divided by 2. Whatever be the case, if S3, S4, S5 is there and time taken is C, so just add V1 plus V2 plus V3 plus V4 by the number. Okay, now if the distance is same, let's say this is A, this is, let's say B, this is, let's say C. Here, just a second, make them equal. C. So distance from A to B is S, B to C is also S. Time taken to complete this distance is T1 and T2. Now, what is the average speed here? So here, distance covered is C. Distance covered is C. Now, we can say the average V average is nothing but total distance divided by total time taken. Total distance is S plus S, 2S. Total time is T1 plus T2. Now we need to Write this expression in terms of velocity. Let's say v from A to B velocity is v1 and from B to C velocity is v2. So we need to write the expression in terms of v1 and v2. That is known to us. So what we can say, what we can do, we can write this t1 as, we know the speed is nothing but s upon t. So this formula we are going to use. So if you replace v with t, so t will become s by v. So t1 will become s by v1, because for s1 the speed or velocity is v1. For t2 the speed and velocity is v2. So you take s as common, it will become 2 upon 1 upon v1 plus 1 upon v2, and this is the average speed. If the distance is same, time is different. Okay, so this is the harmonic mean. Harmonic, in your mathematics you will going to learn about this series, harmonic series. Okay, harmonic mean, the velocity is or the speed. Got it? So based on that we are going to see this numerical. Now what is the numerical says? A particle travels half the distance of a straight journey with a speed of 5 meter per second. Okay. The remaining part of the distance is covered with 6 meter per second for half of the remaining time, and with 4 meter per second for the other half of the remaining time. Find the average speed of the particle. This question includes both the cases that we have discussed so far. Okay. So let's see, we will solve it. How to approach this question? Just write what is given to you first of all. So let us draw a track. Let's say this is point E, this is point B, this is point C, this is point D. Why we have draw this, I will explain it to you. Now the particle travels half the distance of a straight journey, which means let's say this is the distance S and this is another half of the distance B to D, A to B. Okay. Now the particle travels half the distance of a straight journey with a speed of 5 meters per second. So speed from here to here is V is equals to, or let's say V1 is equals to 5 meter per second. Time is not given. No problem. The remaining part of the distance is covered with 6 meter for half of the time. So suppose A to B, it has taken T time. So for B to C, B to D, okay. Let's say from B to D, it has taken time T for B to D or B to D. So what is the time taken for B to C? Let's say T by 2 and C to D be T by 2. That is what it is given in the question. The remaining part of the distance is covered with 6 meter per second for half of the remaining time, and with 4 meter per second for other half of the remaining time. Here, half is for time, not for distance. Got it? Now, and this distance is, we can say, we will not say that this is s by 2 or s by 2. No, it is not given. Half of the time is given. So we will deal with this track B to D with the formula where time is same. In the previous case, if you will see, here we have discussed when the time is same, the velocity average is nothing but the arithmetic mean. So for B to D, for, let me change the color, for B to D, for B to D, V average is equals to what? Which is given 6 meter and 4 meter. 6 plus 4 divided by 2, which is 5 meter per second. Now this is for B to D. A to B we are provided, which is 5 meter per second. But in A to B and B to D, distance is same, not the time. So we are going to apply the different formula for that. Another case that we have discussed where distance covered is same, but the time is different. So here the velocity is nothing but the harmonic mean. So what we are going to do, you can simplify this expression also. I will write it here. When time is same, sorry, when distance covered is same with a different velocity or speed, then you can say that average velocity dash we are getting here is what? This is the actual one. Okay. Or A to D. V average we can directly say if the velocity number of velocities is 2. So V average you can say directly it is 2 V1 V2 divided by V1 plus. Okay. Now 2 V1 you can say 5 meter per second. This V average is nothing but V2. So V2 here is 5 meter per second and V1 is also 5. So 5 into 5 divided by 10, 5 to the 10, 2 will also cancel. So 5 meter per second is the speed, average speed during this entire journey. So this is the right answer for this question. Okay. I hope you are able to understand this. Now move on to the next concept, that is acceleration. So whenever the speed get changed or the velocity get changed, which we have to focus on, we have to focus on the velocity. So acceleration here is the change of velocity per unit time. Okay, it is not a change of speed, it is the change of velocity per unit time. So acceleration, we will say this is a vector quantity, it has direction also. We can say it is delta V vector divided by delta t. Now if you take the magnitude of it, it will come out as delta V by delta t. Now you can say this is the change of speed per unit change of time. Okay, and it is a vector quantity. Okay, it always directed towards the change of velocity. Okay, in which direction the change of velocity is happening, acceleration is on that direction. So either it is increasing or decreasing. Okay, so if I will like to add few points here, if velocity of a system, I'm considering system here, you can take particle, person, object, whatever. So if a system sound too classy, okay. So if velocity of a system is increasing, then acceleration is positive. Okay. If velocity of a system is decreasing, then in that case, the then acceleration is negative. Okay. And what if, and this is also termed as retardation, when it try to decrease the velocity. The motion is itself termed as retarding motion and the acceleration there is retardation. If velocity of the system is constant, then what about the value of acceleration? What will be the acceleration? then acceleration is equals to 0. Okay. Now, based on the discussion about acceleration, we have two types of motion here. First is when acceleration is constant, means acceleration, we have the acceleration, but it is not changing. Okay. So when acceleration is constant, second is when acceleration is not constant. Okay. So when the acceleration is constant, that motion is termed as uniformly accelerated motion. Motion. Okay. And same, but a little bit different. When acceleration is not constant, that motion is termed as, guess, non-uniform accelerated motion. Okay. So these two motion we have here. Now, we do not talk about this for this time. We will only talk about the uniformly accelerated motion. So uniformly accelerated motion may we have three equation of motion. First is V is equals to U plus AT. I will also define the term. This is the first equation. Second is S is equals to UT plus 1 by 2 AT square. This is second equation. And third is V square is equals to U square plus 2AS. This is third equation of motion. Now here V is the final velocity or speed. If you talk about the magnitude, U is the initial velocity or speed, and A acceleration is the acceleration, simple सी बात है, acceleration, and S here is the displacement slash distance. Okay. Now, so these three equation we have, these equation are known as equation of motion. Okay. Now, what about the general equation of motion? These equation of motion that we have dealt earlier, which is uniformly accelerated motion. So this only dedicated to those problem in which acceleration is constant. But what if the acceleration is also changing? So if the acceleration is not constant, acceleration is equals to not constant. When acceleration is not constant, then we can say so the motion equation of motion that we have in a hand is the actual equation of motion or general equation of motion. Okay. So the first equation that we have in a hand is dv is equals to a dt. This is the first equation of motion. Now, second is ds is equals to v dt. This is the second equation of motion. And third is v dv is equals to ads. This is the third equation of motion. Okay. So with the help of this general equation of motion, if you put acceleration as constant, you can also derive the previously got equation, these. Okay. These three equations with the help of this general equation of motion. Got it? Now, based on that, we have questions here. The very first question is on screen is the acceleration of a particle starting from rest varies as a is equals to alpha t plus beta. Now in this question you can see the acceleration is not constant. So we are going to apply the general equation of motion. Find the velocity of the particle at instant t and also find its average velocity between t is equals to 2 seconds to t is equals to 5. Now what we are going to do in this question, firstly we will write what is given. So solution of this question is the acceleration here is alpha t plus beta this. Okay. Now, if I talk about this general equation of motion, we have this relation of velocity with acceleration. So we are going to use this equation in which acceleration is present. Although we have another option also, in this expression also acceleration is present, but here we are taking the integrand with respect to the distance. But in the question, the acceleration is a function of time. So we are going to use that equation in which integrand is time. Now, dv is equals to a dt. dv is equals to, put the value of acceleration is alpha t plus beta into dt. Integrate. Now, one more information is given to you that acceleration of the particle starting from rest. So if it is starting from rest, so at t is equals to 0 second, the velocity of the particle is 0. So at t is equals to 0, velocity is 0. At t is equals to t, velocity is v. Because we have been asked, find the velocity of the particle at an instant t. Okay, so that is why for any general time t, the velocity is v. So integration of dv is nothing but v only, v minus 0. Now, this you can also multiply inside. So it will become 0 to t alpha t dt plus 0 to t beta dt. Now, alpha t dt, integration ka formula I will write here. Integration of x raised to the power n dx is equals to x raised to the power n plus 1 divided by n plus 1. So here we have to apply the same formula. Here x is replaced by t. T has the power 1. So we can say alpha is a constant. So t raised to the power 1 plus 1, which is 2, divided by n plus 1, which is 1 plus 1 is 0 to t. Beta is a constant, so integration dt will become t minus 0 again. It will become alpha t square by 2 plus beta t. This is the velocity at any general time. Now, how to calculate the average velocity in this case? So for average velocity, we know that average velocity, the formula is total displacement divided by total time taken. So total displacement we need to calculate. Now, how to calculate the displacement? We know that thus ds is related to v dt. And the expression of v we already know. What is the expression of v? It is alpha t square by 2 plus beta t. So we can write integration ds is equals to v dt So it is alpha t square by 2 plus beta t dt integrated from 0 to any time t, 0 to s. Because starting from rest, so initially the distance is also 0. Now, okay. Now 0 to s ds, 0 to t alpha t square by 2 plus beta t dt. This is what we have. Now s is equals to, if you integrate it again with the help of this formula, it will become alpha t cube by 6 plus beta t square by 2. Now what you are going to do, you need to put t is equals to 2 here and then t is equals to 5 and then calculate the difference of them, calculate the distance and then calculate the total time. Total time is 5 minus 2, 3 seconds. Then you are able to find out the average velocity. Okay. Now, so I think times is up. So we have covered what we have agreed. Okay. What are the agenda of today? So we will move back to the initial slide. Just a second. Yeah. So we have covered the motion and its type, distance and displacement concept, speed and velocity also. We have seen the instantaneous speed and velocity with a very keen detail, average speed and velocity also. And then acceleration, we have seen a question also with the concept that we have learned in average speed and velocity. Then acceleration, then we have formed the equation of motion and also the general equation of motion and it helps us to solve a numerical problem that we are doing. Okay, so this is it for today. I hope you have enjoyed this session. Next, we will move. I will meet you in the next lecture with lots of numerical, lots of concepts, and lots of fun learning. Okay, till then, take care of yourself. Bye bye, and keep on studying. Thank you so much.